The Special Atomic Demolition Munition, SADM, was a classified nuclear weapons program developed by the United States Navy in the 1960s. It utilized the W54 nuclear warhead, which was housed in an H-912 container and deployed by Special Operations Forces. A two-man team was assigned to place the device at its target, set the timer, and make a rapid escape. For extraction, the team was typically retrieved by a submarine or a high-speed watercraft, allowing for a quick and discreet exit. The W54, also known as the Mark 54 or B-54, was a tactical nuclear warhead developed in the late 1950s. It is notable for being the smallest nuclear weapon ever deployed by the United States, both in weight and explosive yield. The compact design featured a plutonium-239 implosion device, with modifications enabling yields ranging from 10 to 1,000 tons of TNT, 42 to 4,184 gigajoules. The warhead had two primary applications. One version was integrated into the AIM-26 Falcon air-to-air missile and the Davy Crockett recoilless gun, while another was specifically designed for the SADM system. Development of the man-portable version began in June 1960, leading to the creation of an interim model, the Mark 54 Mod 0, later B-54-0, in April 1963. A more refined version, the B-54 Mod 1, entered production in August 1964. The weapon measured 12 inches (305 mm) in diameter, 18 inches (457 mm) in length, and weighed 58.5 pounds (26.5 kg). It included a warhead, a fusing and firing system with a mechanical timer, a ferroelectric firing set, and a sealed housing. The warhead's body was constructed using aluminum forgings and molded fiberglass, with foam rubber insulation between the warhead and its casing. To support nighttime operations, tritium phosphor paint illuminated the dials, and a specialized housing allowed for underwater deployment with external controls. In June 1965, production of the B-54 Mod 2 began. While it retained similar dimensions, the Mod 2 incorporated design improvements and weighed slightly more at 70 pounds, 32 kg. The Atomic Demolition Munition (ADM) employment manuals outlined potential defensive uses for these weapons in combat engineering operations, specifying targets such as bridges, dams, canals, tunnels, airfields, railroad marshalling yards, ports, industrial plants, and power facilities. The manuals also included detailed tables to determine the appropriate yield for each target. These calculations took into consideration factors like burial depth, fallout effects, and the minimum safe distances between personnel and nearby detonations. On December 27, 2018, the Green Bay Press-Gazette featured an interview with Mark Bentley, a veteran who had trained in the Special Atomic Demolition Munition (SADM) program. Bentley, along with other trainees, was tasked with manually placing and detonating these devices. According to the article, the soldiers involved in the program understood that their missions were essentially suicidal. Escape from the blast zone was often considered unrealistic, either because it was too difficult to get out of range in time or because they were required to stay at the site to secure it until detonation. However, the ADM employment manuals outlined a planned retreat procedure for the team and their security personnel. Once the device was positioned, defense relied on both passive and active measures. Passive defenses included concealment, camouflage, and decoys. Active measures involved booby traps, obstacles like concertina wire and landmines, and the use of long-range artillery to deter enemy interference. Additionally, the SADM featured a field wire remote control system, FWRCS, allowing operators to safely send activation and detonation commands through a wired connection, enabling remote weapon activation. When used in the Davy Crockett role, the SADM was equipped with two distinct fusing systems, a radar-based fuse for a 40-foot 12-meter airburst, and a capacitance-based fuse for a 2-foot 0.61-meter airburst. These settings enabled both high and low airburst detonation options, optimizing the weapon's effectiveness in varying battlefield conditions. The device contained 26 pounds, 12 kilograms of high explosives. There is some inconsistency regarding the explosive yield of the different versions of the W54 warhead. Some sources estimate that the Mod 0 version had a yield of 250 tons of TNT, 1,000 gigajoules, while the Mod 2 was rated between 10 and 20 tons of TNT, 42 to 84 gigajoules. However, declassified development documents suggest that the primary difference between the two variants was the environmental sensing devices. And since the warheads were field convertible, it is believed their yields were essentially the same. Official records list the yield of the warhead as 20 tons of TNT, 84 gigajoules, when used in the XM388 round for the Davy Crockett system. The M28 and M29 Davy Crockett weapon systems were tactical nuclear recoilless smoothbore guns developed to launch the M388 nuclear projectile, which was armed with the W54 warhead. These systems were deployed by the United States during the Cold War as part of a strategy to provide mobile battlefield-level nuclear capability. The Davy Crockett project was the first assignment given to the United States Army Weapons Command in Rock Island, Illinois.